As we discussed earlier in the fan clutch basics video, a two-speed fan clutch uses some mechanism to keep the fan spinning at low RPMs even when the fan clutch is in the off or disengaged position. This low RPM rotation simulates ram air and provides significant cooling, which reduces the number of times that the fan clutch must fully engage. A general rule is that a fan clutch should not be in the on position more than 10% of the time. If a fan clutch's on time exceeds 10%, the fan clutch will likely fail prematurely. The two-speed mechanism varies from manufacturer to manufacturer, but the target result is the same: to reduce the number of fan clutch engagements. It is the combination of airflow across the radiator and the engine coolant that keeps the engine within normal operating temperature. However, if you remove the airflow, the engine coolant itself is not enough. In an over-the-road application, because there is a high amount of airflow, the engine stays within normal operating temperature and the fan clutch rarely needs to come on. In vocational applications, where the vehicle is often at low speeds or idle, there is a lack of airflow across the radiator. Because of this, the engine temperature constantly rises above normal operating temperature and the fan clutch has to continually cycle to keep the engine cool. In these applications, where the fan clutch on time is greater than 10% of the engine runtime, a two-speed fan clutch is ideal. Good examples of this are cement trucks, garbage trucks, dump trucks, and so on. By installing a two-speed fan clutch in these applications, you will reduce the number of fan clutch engagements to an acceptable level. This will prolong the life of your fan clutch, but is also beneficial because it will save horsepower, improve fuel economy, and produce less noise. The Horton two-speed fan clutch uses magnets to create this low RPM fan engagement. Magnets are usually placed on the outside edge of the pulley in close proximity to the overhanging fan plate. As the pulley rotates, the magnets will pull the fan plate and therefore the fan blade at between 20 and 30% of the pulley RPM. Kitmaster's two-speed GoldTop uses an internal chamber that is filled with viscous fluid. Inside of this chamber is a flat disc that rotates along with the pulley. As this disc rotates through the viscous fluid, it causes the fan plate to drag, thereby causing the fan to rotate at 20 to 30% of the pulley RPM. If you've watched our video demonstration of the benefits of our GoldTop, then you already know that the number one cause of failure in OEM on-off fan clutches is pulley bearing failure due to lack of torque. Kitmasters has solved this problem with their GoldTop fan clutch rebuild kit. At the base of the two-speed DriveMaster is a DriveMaster. Therefore, the primary cause of failure in a DriveMaster two-speed is still pulley bearing failure. At the base of a GoldTop two-speed is a GoldTop. It is still a GoldTop in every way. It still packs over 5,000 inch-pounds of torque, which means that it can handle any fan blade in the industry. It is just as easy to install as an on-off GoldTop. In fact, the installation process is identical. And it also features our patented fail-safe system, AutoLock. In addition to having the same benefits of the on-off GoldTop, the two-speed GoldTop also has the additional benefit of using viscous fluid instead of magnets. Both magnets and viscous fluid are able to achieve roughly the same output RPM, so the difference isn't in the speed of the two-speed. However, another primary cause of failure in some two-speeds is faulty magnets. The magnets are designed to achieve 20 to 30% output, and since a magnet doesn't really lose its magnetism over time, it should produce the same output forever. However, the primary enemy of a magnet is heat. Magnets are designed to hold their magnetism within a certain heat range. If the magnet experiences heat too far beyond the specified range, it will immediately cease to be a magnet. Consider that the magnets in this fan clutch live inside a heavy-duty engine and are specifically next to engaging and disengaging friction material. Further consider the torque story we discussed in the GoldTop section. Lack of torque causes slipping, which creates heat, which causes the pulley bearings to prematurely fail. that same heat will cause the two-speed magnets to fail. Quite often, one of the most difficult aspects of rebuilding a two-speed fan clutch is finding the proper kit in the first place. OEMs have numerous different rebuild kits, with every revision receiving a new part number. To make it more difficult, the OEM often makes you purchase multiple part numbers just to rebuild one fan clutch. Typically, the fan clutch rebuild kit is one part number and the bearing kit is a completely separate part number. Then there are variations of the rebuild kit with different stud lengths, and each of these variations is another part number. All of these part numbers make it confusing and difficult to find just what you need. On top of all of this confusion, sometimes the fan clutch fan pilot is 2.56 inches and sometimes it is 5 inches. This may be another kit to purchase, or it may mean you also need to purchase a new fan blade. When you purchase a 2-speed GoldTop rebuild kit, you get everything you need in one box with one part number. Since you should always replace your bearings when rebuilding your fan clutch, we include them with every GoldTop kit. And you can forget about needing to buy a different fan blade. The 2-speed GoldTop comes standard with a 2.56-inch pilot, but with a simple adapter ring, which is included, you can transform it into a 5-inch pilot. Just use our cross-reference in our catalog or on our website to find out what kit you need, and then rest assured that you'll have everything you need to rebuild your 2-speed fan clutch.